So for problem number 5, we're looking at two functions, right? And we just want to find where along these two graphs is the vertical distance between them a minimum. And so if you just kind of think about vertical distance, if we're just looking at this, say, from right to left, you can see that the distance as we're moving, it's getting shorter and shorter and shorter. And then you get to a certain point where the distance starts to increase again. And so we're wanting to know, where is that distance the shortest? And what is that distance? Well, let's just, pick 2 points along this graph and let's calculate the distance between those 2 points. We'll call one of them x1, y1, and the other one we'll call x sub 2, y sub 2. And if we apply the distance formula, this is what you'll get. And you'll notice that the difference in your x values, they don't change. Okay, if they're vertical, if the points are on top of each other, then there is no difference between the x values. So that guy's always going to be 0. So basically what we're really looking at is just the square root of y sub 1 minus y sub 2 squared. Well, if you take the square root of something squared, you're just going to have y sub 1 minus y sub 2. And that's really what we're trying to minimize, is that distance. Well, what is y sub 1? It's x squared plus 1. And then we're going to subtract from that y sub 2, which is x minus x squared. And if we clean this up a little bit, we end up with a simplified equation, 2x squared minus x plus 1. All right? So that function, 2x squared minus x plus 1, that represents the distance, the vertical distance between those two graphs. And I want that vertical distance to be as small as possible. So I'm going to take the derivative of that and set it equal to 0. And when I set it equal to 0 and solve for x, I get x is equal to 1/4. So sure enough, if you look at the vertical segments that I constructed, it looks like about 1/4 is kind of right. It's right where we would think that distance is the shortest. What is that distance? Well, we would just take 1/4 and just plug it into that distance formula that we came up with earlier, and you get the distance is 7/8 or 0.875.